Guys, in this video we're going to look at another example of solving a trig equation, but trig equation like number 16 here, specifically where it looks like, hey, maybe I should be able to factor this, but my problem here is that I have different types of trig functions in the equation. And so a neat technique that we can use here to help us solve one of these is to just make a Pythagorean substitution. That is to say that looking at something like number 16 here, because I have a cosine squared but then a sine to the first power, maybe what we could do is we could say, well, cosine squared is squared, and because we know that cosine squared plus sine squared is 1, we could make a substitution for cosine squared by isolating it and getting this expression or equation here, cosine squared is 1 minus sine squared. And by plugging in 1 minus sine squared for the cosine squared, everything would be in terms of just sines. And so let's take a look at what this might look like here. I suppose that we would get 2 times, in parentheses, 1 minus sine squared of, I'm going to use x here, plus the sine of x minus 1 equals 0. And so the first thing I'm inclined to do is to go ahead and simplify. We'd have 2 minus 2 sine squared x plus the sine of x minus 1. And like we do with polynomials, we like them to be in standard form. Well, same thing with trig equations. So let's put this term up in front. We'd have negative 2 sine squared of x plus the sine of x. And then combining like terms here, this positive 2 and negative 1 would give us a positive 1 equals 0. And then last but not least, I could factor this, but I tend to like to factor things that have positive leading coefficients. And also because this equals 0, it's not really going to affect much. Even if it didn't equal 0, it wouldn't affect much. But we could just go ahead and multiply everything by a negative or a negative 1, and this would be having something that is a positive leading coefficient. So if I were to multiply both sides times a negative 1 times negative 1. Then I would have positive 2 sine squared x minus sine x minus 1 equals 0. And from here we could just go ahead and proceed with our factoring method. So let's go ahead and finish this out. I suppose factoring wise, we'll do a little guess and check here since we have a non-1 leading coefficient. So we're going to have to start with this. It would have to have a 2 sine of x and a 1 sine of x here to multiply out to be 2 sine squared of x. And then in terms of what would multiply out to be a negative 1 in the back there, well, I would be inclined to just write plus 1 minus 1. And that would at least take care of that. Now in terms of do I get my outer and my inner term here to add up to be negative sine x, let's check. My outer would be negative 2 sine, my inner would be positive 1 sine. That adds up to be a negative sine x. So these being our two factors here, if we set them each individually equal to 0 and solve them, we get 2 sine of x plus 1 equals 0, and we also get the sine of x minus 1 equals 0. So let's start with this. Let's isolate the trig functions where possible. We can here. So we're going to subtract 1 and divide by 2 over here. This leaves us with then the sine of x equaling a negative a half, and it follows that when we take the sine inverse of both sides, we get just the angle then is the sine inverse of negative a half. I'm going to put a box around that. Now over here, we'd add the 1 to the right-hand side, so sine x would be 1, but also it would follow then that x is sine inverse of 1. We do have to list that here. Okay, so now we're going to go and start to assess the situation with what my angles would have to be here. Let's start with where sine is negative a half. So in terms of a sketch, maybe I'll put my sketch over here. I got a lot of room for once in my videos here. We say A, S, T, C. If sine is negative, first things first, our angles have to terminate down in one of these two quadrants here. Okay. And then next thing is this, sine is a half, but only at what type of a reference angle? Let's go check our circle here, and we'd say only at a 30 or a pi 6. Now keeping in mind that this says I want to do this between 0 degrees and 360 degrees, we're going to do this in degrees. So what that means is I'm just going to mark the reference angle on both of these as being 30 degrees big. So what are the actual angles? Well, suppose we would have 30 degrees past 180 degrees, or at 210 degrees, so we would say x equals 210 degrees, but also at this angle here, which is at 330 degrees here. So let's go ahead and write that in, 330 degrees, and I'll put a box around this. And then where is where is sine equal to positive 1? Well, that only happens in one place on the unit circle, and that's up here at 90 degrees. And so we would say the other solution here would be x is 90 degrees. So the last thing I'd have you do is just go ahead and check on your unit circle. These things would be really easy to determine as well. Sine is negative a half right here and right here. And so at 210 and 330, like we said, but also it's equal to 1 up here at 90 degrees. So once you get through doing this, it's always good if you have it available to you, check your unit circle to reference that. But yeah, we sometimes are going to need to make Pythagorean substitutions in order to be able to factor something.